VLPSos here. This is a video lesson for Python programming. Text. This code file started as stub1. I'm in the habit of including my code files with subdirectories, images, and sound effects for resources, though I'm not going to be importing any sound effects and images in this program. I do have my palette of colors to import so I can use the colors from the dictionary that I call palette. In this program, what we're going to do is we are going to display written words as graphics on a graphic surface. We're going to render fonts, which is a way of converting strings into graphic surfaces, so that we then blit the graphic surface and see the string or the written word. We're going to prepare to do that by first creating a variable called point, which will serve to be the size of the font that we are going to render. And we need a font, which is a string naming the font that we're going to use. Times New Roman is a font. It's one amongst a handful that is freely distributed and available on operating systems and computers quite universally. Your Python programs can make use of any font that's on your computer system and is recognized by your operating system. But not all fonts are on all systems. So there's a danger that if you include a font in your program and then you want to run your program on another computer, that computer might not have the font that is being used by your code. So if we want to write programs that are distributable, and we want to use fonts that aren't of the standard set of fonts, then we need to make sure that we distribute the font with our program, which might include some licensing and paying or giving attribution to those that created the font and made it available to you. Times New Roman is freely available to use. Now that I have my point and font, I'm going to write a line of code that I often put in the screen settings section before the frame loop. And I choose the variable font setting to be a call to pygame.font.sysfont, in which I put into the argument of the sysfont function the font that I am going to use and the point, which is the size. This line of code sets up a variable to represent a way of accessing the font that I've chosen, the font and the size that I've chosen. So this variable font underscore setting is going to be used to create or to render graphic surfaces that then I'm going to blit to my screen. So now that I've got that set up and ready, under draw objects in my frame loop, I'm going to make one of those graphic surfaces of the written word. So I'm going to choose a variable. I like to choose the variable printline because it represents what I'm thinking of it. It's a line of print that is going to be put onto the screen. That variable is then equal to the font setting that I created, and the render function called on font setting. So this is font setting.render. The render function is what's going to create a graphic surface out of a string and then assign it to be the variable printline. Printline is going to stand for a surface. It's a variable whose value is a surface with a width and a height, filled with pixels of color that will then be that font drawn onto that surface, or that string that I'm going to put on that surface. So printline, once I create it or render it, will then be blitted to the string just like a common graphic or image. So let's finish rendering this line. What I'm going to render is the string. Could be anything. I'm going to choose something fairly simple. Hello graphic text. The render function also needs two other parts in its argument. The string is the first part. The second part is a Boolean of whether I'm going to use the anti-aliasing algorithm to smooth out the text or not. If I put a Boolean of false here, I am not using the anti-aliasing algorithm to render that font more crisp and more smooth. Anti-aliasing makes our text look better, quite a bit better, but it's CPU intensive. So if you have a slow computer and you want your program to run quickly, then not anti-aliasing your text might be your choice. The third part of this argument is the color that the rendered string will be in. And from my palette of colors, I'm going to make a variable called color and assign the variable color before I render the text. It will be a string, and we're going to choose white. So white is a key in palette, so when that variable color is used, it will be the white color that renders this hello graphic text string into a graphic surface. Then is the value of printline. Now that printline is a surface, I can blit it to the screen in order to see it. So we'll do a common screen.blit. The blit function is going to blit printline to the screen, and where it's going to be blit it to will be the top left corner, the coordinate 0, 0. If I save and run, I can see that hello graphic text surface on black in white and not anti-aliased, blitted to the top left corner. A size or a point of 80 is quite large. Let's do something a little more sophisticated. I'm going to copy. Well, first, I'm going to center horizontally the printline surface that I saw. I don't want it stuffed over to the left, I want it centered. So I'm going to do a little bit of math for the x coordinate that I need in order to center that print line on the larger screen or the wider screen. I don't know the width of printline. Printline is a surface, but the render function created a surface that was perfectly sized to receive the hello graphic text in size or 0.80, and it dynamically created the width and height of that surface in order to get that text there. I didn't set it myself, but I need to know that value if I'm gonna center it on the screen. I can get the width of the print line dynamically every frame by the get underscore width function. So this line of code will stand for the width of the print line that was just rendered. I want to get the difference between its width and the screen width. So if I take the screen underscore width, which has been defined in my stub, and I subtract them, I get the difference between the screen width and the print line width, which might be kind of small because the print line is fairly large. Now I need to take half of that difference in order to know how much to bump it over horizontally. The x coordinate, I need to know how much to bump it over from the left side of the screen so that the difference, half of the difference, is on either side, making the print line centered in between. So I have the difference. It's now time to take half of it. I put it in parentheses and divide by 2, which turns it into a float. And if this is going to be an x coordinate of pixels, it needs to be an integer. So I'm going to turn it into an integer by putting it into the integer function. Now finally, this represents the x value to blit this print line to center it. So let me give this x value a variable name. It'll be descriptive. It'll be text underscore h for horizontal position. That's how I'm using that value. And instead of blitting at 0, 0, I'm going to make use of that value as the x value. Let's see if it centers it. I had to do this dynamically because remember, I don't know what the width of that print line is before it's rendered. But I can see it centered now, and I want to push it down from the top by a little bit, so I'm going to give it a y value of 100 instead of 0. The next thing I'm going to do is I'm going to copy all of this, and I'm going to change the second thing that gets created by changing the string that gets rendered. I'm going to make this string a little more sophisticated. I'm going to put a %s to stand for a string value, and then the word at and a %i. And the values are going to be supplied, or the string is the name of the font, and the integer will be the size that we call point. I'm also going to blit this 200 further down than the first, so at a y coordinate of 300. Let's see what we got. Oh, before I do that, I'm going to turn the anti-aliasing on by changing the value of that Boolean in the argument of render to true, so we can compare something that is anti-alias to something that is not. Let's see what we got. We have them both centered because the math is being done dynamically before it blits it. And I can see that the text above looks sharper. It's been anti-aliased, and we can compare it to the name and the size of the text above it that is not anti-aliased, and it's got pixelation on its edges. So let's make this a little bit more fun by displaying many different fonts or several different fonts at different sizes and possibly different colors. So we're going to prepare that. We're going to prepare for that by uncommenting this that got written before, which is a list of a handful of the fonts that are common to most systems. Times New Roman is one of them. There's also Helvetica, Arial, Veranda, and Courier, which look quite nice. So we have a list of fonts available. And before we render them, I'm going to get the color randomly with the random.choice function, which will choose randomly from a list. So the list I'm going to supply is going to be putting all of the palette keys into the list function. So it chooses at random one of the keys in the palette. The palette is all the colors that are available in the palette code file. And so we're choosing randomly from those colors. So the color is now going to be randomized here. But it will be randomized only for one. We'll stick with white for the second string by changing this to just be the string and color white. We're also going to choose a font at random. Let's make some space. And a comment for what we're doing. Choosing fonts and the size will mean that our font variable is reassigned to be something random now from the list of fonts that we wrote before. There are 5 fonts in that list. The point is going to also be chosen randomly. But it's going to be chosen randomly from a range of integers. And that range will be from 4 to 50. But we're going to copy this and be the sum of 2 ranges from 4 to 50. So the true range, if we add these, there's going to be 8 to 98 because we don't get 50 as the top of the range. And the reason why we did that is because we're going to have fonts that have a tendency to be closer to size 49 if we're adding two ranges, equal ranges. So we'll get more fonts that are about medium sized and fewer that are very small and very large. Then we need to reassign our font setting because we've changed the settings. Now we're changing the settings every frame. So font setting needs to be equal to pygame.font.sysfont with the new font and point. This is going to change it every single frame, and we have some random colors. Let's see what we got. Well, our call to create keys must be plural. It's the keys function, not the key function, that creates the keys. And what we got is what I might have anticipated. Every single frame, we're choosing a different font from the list and a random point, and we're just using it to display those two. It's processing too quickly in order to really see or appreciate what's being drawn. So we need to slow it down. And the way that we're going to slow it down is we're going to base it on frames again. So the changing of the fonts is going to be done as we count frames. And if the frame count is greater than or equal to frame change, a number that the frames have to count up to in order to be high enough to trigger this change, and we want to immediately reduce our frames by the frame change. So this math, if we declare what frame change is, the greater it is, the slower this processing will be. And let's slow it down. I have a fairly fast computer, so it's 3,000. This reasoning and this math and this technique has been used before. We can have other things to replace how to control time. We have lessons on how to do that in the future. But again, this is counting frames, one per frame. So as our frame loop goes by, the value of frames goes up. And if it reaches 3,000, then it triggers this code block to be run, and it also goes down by 3,000 so it can build back up. It's going to be periodic that when this code block gets run, which then changes our font. Let's see the effect. We have a coloring cycle. We probably want to put the color in there so that the color gets held instead of has a strobe effect. But we can see that we're getting different fonts created and blitted at different sizes, and the name of the font and the size is also displayed in white below. Let's just calm down those colors by putting that into the periodic section of our code. Need to predefine color if we're going to only run it behind that code block. And we can see at a reasonable pace what our graphics look like, our graphic text looks like. Now you have seen how strings can be made into graphic surfaces and blitted to be seen by the user. Make a simple program that blits 3 things to the graphic screen so that they may be easily read. A message from you, the location of the mouse as a tuple of 2, and the frame count. Have fun.